Hello, this is Miss Piekarski. Um, I should give you a warning, this video is going to be a little bit longer than the other videos, mainly because we're going through about 2.5 pages of your notes. I am not going to do everything in the video that's on your notes. Some of it you will have to do on your own, so please pay attention and make sure you pause the video when you need to so that you can finish filling out the notes and then move on. All right, so find this page in your notes. In this page you have a graph and you have lots of different lines here. Well, and these are all the equations that are graphed on this graph. If you notice that every single one of these functions has x-intercepts at -3, at 0, and at 3. And there's only slight differences and slight variations on these hills here and here and how far the lines spread out on over here. But your x-intercepts are all the same. So that tells us that the factors are all going to be pretty similar. There's only one slight variation. So if you take these equations, if you take each one of these and go ahead and factor them out, you have x cubed minus 9x. Well, your greatest common factor there is an x. You can pull out one x from both of those terms. Well, when you do that, you end up with x times x minus 9 squared. Okay? Well, and then you can take this x minus 9 squared and go ahead and factor that as well, and you get x minus 3 and x plus 3. So that's where we're getting the three factors, or our three x-intercepts. So if you set this term equal to 0, it's x equals 0. If you set this term equal to 0, you get x minus 3 equals 0. You add 3 to both sides, and then you get x equals 3. Over here, if you do x plus 3 equals 0, and then solve for x, you get x equals -3. So that's where your three intercepts come from, the -3, the 0, and the +3. So each one of your equations can be, what am I going to say? Sorry, they can be factored with these three terms, the x minus 3, and the x plus 3. There's going to be one little thing that's different. Well, on the B, you have a 2 here and an 18 here. Both of those terms can be divided by 2, so you can get rid of a 2 and an x. And then on E, whoops, why did I put E? Sorry, F. On F here you have -1/3. Well, if you factor out a 1/3, and this one is a little bit more complicated because basically what you're doing, you're taking the whole equation and you're dividing by 1/3. So if you divide by 1/3 here, you end up getting that -1/3 out to the front, and then -3 divided by 1/3, you end up multiplying by 3 there because you have a fraction and a fraction. So you'll end up multiplying by 3 and, whoops, yeah. Anyway, so that's how for f, this should be f here. Just pretend that's an f of x. Okay, so for f of x, your leading coefficient is -1/3. And then you'll have all the correct factors. All right, so in this case, the only thing different between all of your terms, or all of the formulas, is the leading coefficient. Let me get rid of that. There we go. All right, so your leading coefficient is the only thing that's different between all of those formulas. So let's see, I did A, I did B, so you need to find the leading coefficients for C and D on your own, and then go ahead and move on. All right, so the next page of your notes that we're going to go over, this is just talking about how if you have factor terms, you can find out what your leading coefficient is if you have one other set of variables in the equation. So in this example, you have the x-intercepts at -6, and you have an x-intercept at 4. So you get your factor terms. minus -6 becomes x plus 6, and then x minus 4 is your other factor term. Well, we need to find the leading coefficient, your a value. Okay, in order to do that, we need to get one more intercept somewhere, one more set of numbers. In this case, my y-intercept is 0 and 12, and I'm going to replace my x, all my x's with 0, and I will replace my f of x, or my y, with 12, and then I'm going to solve for my a value. Okay, so that's essentially what they're doing up here. So they're replacing x with 0 and y with 12, and you end up finding out, you solve for a, and you end up finding out the a equals -1/2. Well, you can go ahead and plug that into your factored equation, but then you need to go ahead and FOIL or use the box method to figure out what the standard form of the polynomial will be. Okay, so to write it as a polynomial, all they did is they multiplied and distributed, or FOILed or used the box method, either one. Okay, so, and then in your notes you have two examples. I will go through step by step with the first example. The second one I'll get you started, and you'll have to move on, go from there. All right, so you find a cubic polynomial function with, hold on. Oh, this is really weird. You know what, hold on. I'm going to get rid of that because that's not the right wording on that. Let me find it really quickly. Sorry, guys. While I'm getting this figured out, I want you to go ahead and finish the other problems if you haven't done so already. Let's see. Finding a way is what I got this problem from. There we go. All right, sorry about that, guys. Here's our problem. Let me make it smaller so it doesn't cover up everything else. So we want to find a cubic polynomial function with x-intercepts at -3, 4, and 6, and it also passes through that point. Okay, so when you set up your factors, this -3 here becomes the factor x plus 3. The 4 becomes x minus 4, and then the 6 becomes a factor x minus 6. Okay, so those are all our factors, and we're looking for our leading coefficient. So I have the 5 for an x value and a 12 for a y value. So I'm going to replace my x and my y with 12 and 5. Notice all my x's are 5s now. So in each parentheses, 5 plus 3 gives me 8. 5 minus 4 gives me 1, and 5 minus 6 gives me -1. Okay, I'm going to multiply those together. I get 12 equals a minus 8, or sorry, a times -8. Don't make that mistake, guys. And then I divide by -8, and I get 12 over -8. I reduce that to -3/2, or the decimal -1.5. Okay, so that's now my a value. So my equation becomes this, and this is the factored form of the polynomial. I want to go ahead and FOIL that, and I can multiply my first term by -1.5, so 1.5 times x, and then -4.5 is it comes from the -1.5 times 3 becomes 4.5. Okay, now I have two other terms, the x minus 4 here and the x minus 6. I went ahead and FOILed that. I get x squared minus 6x minus 4x plus 24. You guys already watched the video on FOILing. Everybody should remember how to do that. I can simplify that further, and I get the two terms, this term and then this term. But then I need to either FOIL it again or use the box method. Anytime I have more than two terms, I like to use the box method. It's just easier. So right here on the top, I'm going to have x squared, negative 10x, and then 24. And then on the sides, I'm going to put the negative 5x from here and the negative 4.5 from here. Okay, so I just set this term here, whoops, this term is on the top and this term is on the side. All right, so x squared times negative 1.5x gives me negative 1.5x cubed, and negative 4.5 times x squared is negative 4.5 times x squared. Here, the negative 10 times negative 1.5 gives me negative 15, and then x times x is x squared. Negative 10 and negative times negative 4.5 gives me 45, and then times x, and then I keep doing my math, and I get these terms in my box. Okay, so then I go through, and I just set up your polynomial. So your first term, negative 1.5 times x cubed, and then add these two terms together, or subtract in this case, and you get 10.5 times x squared, and then the 45 and plus the negative 36x gives you positive 9x, and then at the end you just have negative or minus 108. All right, so that's a lot of work just for this one problem. Okay, you have another problem very similar to that to do. I'm going to show you how to find your A value again, your leading coefficient, and then you have to do the rest on your own. Please make sure you get it all done. I know it's a lot of work on this one. So in this case, you have find the cubic polynomial function with an x-intercepts at negative 2, 2, and 4, and you pass through the point 0 and 8. So start setting up your factors. The negative 2 becomes a factor x plus 2. The 2 here creates a factor x minus 2. Excuse me. And then the 4 here becomes x minus 4. That's our factor. Now your a's, you're looking for your leading coefficient. Replace your x's with 0 and replace your y with 8. And you get this. Go ahead and simplify each formula that's in parentheses. And you get 8 equals a times 2 times negative 2 times negative 4. Go ahead and do all the math. You get 8 equals a times 16. Divide both sides by 16. And we get all those out. You get a equals 1/2. So now your polynomial in factored form is going to look like this. Go ahead and FOIL everything and see what you get. I will tell you your final answer should be y equals 1/2 times x cubed minus 2 times x squared minus 2x plus 8. That should be what your final answer is. I do need to see your work. Either FOIL it or box it. Okay. Tomorrow when you come into class, you're going to have some problems. You'll have two problems like these where it'll just be word form. They'll tell you where the x-intercepts are and you have to set up the factors. You're also going to have two problems like this, or no, actually I think you'll have three problems like this where you just have a graph and you have points along the way. Okay? In this case, when you have a problem like this, you're looking for your x-intercepts. The nice thing is all these x-intercepts land on tick marks. So in this case, for this example, you have a x-intercept at negative 1 here, so you get the factor x plus 1. You have a x-intercept at positive 3, so you get the factor x minus 3. Notice I'm changing the sign each time. And then you also have a x-intercept at 5, so you get the factor x minus 5. Okay, you have this extra point, the 1 in the 20 or 1 in 32. So your y is going to be 32, and your x's are all going to become 1s. Solve for your leading coefficient. We just want to know what is the leading coefficient. So solve for that. Do your math, and you find out that your leading coefficient is 2. And these are all your factored terms. Go ahead and do all the work. Show me all your work on foiling or box method to find your actual polynomial. And your final answer should look like this. If it doesn't look like that, go back, make sure you've added everything correctly. Make sure if you have a negative, you treat negatives the way they should be. You're subtracting your whatever, okay? And if you have two negatives, that makes a positive. So watch your negative signs. Most of the time, if you mess up, it's usually because of the negative sign. So watch those. This should be what your final answer is in your notes. One more example. Okay, here's one, and I showed you how to set up the factored terms. You have an x-intercept here at -2. You have an x-intercept at 0 and an x-intercept at +2. Notice that with this x-intercept, I'm going to change my color and make this bigger. So this x-intercept right here, you hit the x-axis, and then instead of crossing it, you bounce back. Well, anytime you do that, anytime you're bouncing back, your exponent, or excuse me, you're going to, whatever that term is, that factor term, that factor, you're going to raise it to a power of 2, 4, 6, 8, 10, 12, something like that. Okay? So basically that's telling you you have more than one x-intercept right there. Okay? I'll kind of review this concept a little bit tomorrow in class, but I really need you to understand that anytime you hit the x-axis and bounce back, go ahead and square that factor term. Yes, it could be x plus 2 to the 4th power or the 6th power, but you'll never have problems like that in this class. You might come across one in college algebra or college pre-cal, but in high school pre-calculus, just square it for me, please. And then so your other terms, because you hit the 0 is your x-intercept, you could do x minus 0, but the 0 isn't going to do anything. So just leave it as an x, and then an x minus 2 for this x-intercept right here. All right, so those are your factored terms. Again, you need to solve for your a value. You have a -1 and a 9 here, so replace your x's with -1s and replace your y with 9. Find your leading coefficient, and then multiply all your factor terms together to find your polynomial. And when you do all of that work, your final answer should be right here. Okay? I know I went through this very quickly. Please go ahead and review it again if you need to. Pause it again if you need to. All this work needs to be done. Even if I didn't show you how to do it in the video, you should know how to do it. We've gone over it before. If you need to, watch some of the other videos on the box method and all that fun stuff. All right, get all your notes filled out, have them in class tomorrow, and I will see you then. Bye.